Hi, in this video I try to show you how to find the principal axis from the given quadratic form. This is actually a linear algebra question. They will give you a quadratic form like this, and you need to find the principal axis of this equation. Also, you need to express in diagonal form. What to do first? You need to just arrange this quadratic form equation, these equations into a matrix. Like, you need to convert this into matrix, and easy way to do this, look at this. It's x1 and x2. There are two variables, so it's better if you just write x1 x2 this way and x1 x2 that way, so that you know which number is going where. So this is x1 squared, means these two will go when you at this place, because x1 and x1 is x squared, so 2 will go here, and this is x1 times x2. So there are two places. Look at if you can see x1 and x2 and x1 x2. So you need to divide this 12 into two groups, which is 6 and 6. So 1 6 will go here, 1 6 will go there, and then minus 3 is x2 squared, which means x2 and x2, it is going here. And if there are more variables like x1 x2 x3, you have to just extend this x1 x2 x3 here, x1 x2 x3 here, and the same way you need to just put these numbers into the matrix form. Now when you get this matrix A, you need to find the eigenvalues of this matrix, and you can choose lambda or you can choose x, doesn't matter. So subtract this lambda from the diagonals, and then you know how to find the eigenvalues, right? So you need to close this. You can select this and then close this up. So you have minus 3 and lambda left. You have to multiply this with that. Similarly, then you have to do minus, because this goes by plus, minus, like that. So, and then you're taking 6. So take 6, which is this, and then you can close that. Then 6 is left. You have to multiply that 6. When you multiply that and simplify, you will get two eigenvalues here, and I found x is minus 7, or lambda 1, which is eigenvalue. First eigenvalue is minus 7, second eigenvalue is 6. Next step is, for each of the eigenvalues, you have to find eigenvectors of this matrix A. So for minus 7, first eigenvalue, to just find the eigenvectors. If you need to know how to find the eigenvectors, you can watch other videos in YouTube, and that will be helpful. So for getting the eigenvectors, you need to just subtract this eigenvalue from the diagonals, then whatever matrix you get, then do the row echelon form, and then do the system of equation, and you will get the eigenvector. So for so lambda 1, I get the eigenvectors, eigenvector these. Similarly, you have to find the eigenvector for lambda 2, which is 6 here, and if you do the similar method, you follow the similar method, then you will get the eigenvector that. So when you get these two eigenvectors, you need to just normalize it. Normalize means you can use this formula 1 by this v vector, like you have to just square root each of the eigenvectors here, like the values of the eigenvector, and then multiply the vector itself. So it is the first eigenvector was 2 minus 3, so you just take these, normalize it, you will get that eigenvector, which is normalized one. Same way you find the normalized eigenvector for the second eigenvector, for the second eigenvalue, which will give you this. Now you have the eigenvectors, which is normalized one. This is here, and that one is there, and you can simplify. Like you see, there's a root over 13 on each of them. I just separated 1 over root over 13, so I get simplified version of this normalized eigenvector, which is the P. Now To make the equation, you need to use this formula. y1, y2 is equal to transpose of this p, the p you found, and times by the x1 and x2, which is an eigenvector. And then simply multiply that, like 1 over root 3 and 2x1 minus 3x2 x, and same way 1 over root 13 3x2 plus 2x2. That is the equation. And to get the diagonal form, they said all you have to do, you have to just take this eigenvalue 1 and eigenvalue 2 and put in the diagonal form, which is this. So just put the two eigenvalues and the other two would be 0. If there are 3 of them, so 3 eigenvalues and the rest of them would be 0. And the q would be like eigenvalue first y squared and the eigenvalue second y2 squared. So they will ask you to find this y1, y2 equation, the diagonal form, and the equation q. This is how you need to find. Thank you.